Welcome to the lesson on teaching strategies for raising questions and formulating problems. In this lesson, we will be looking broadly at multimodal and visual thinking and introducing some teaching strategies and activities that you might incorporate into your own classroom. Some of the intellectual standards most aligned with raising questions and formulating problems might be, is this a significant question to answer or problem to examine? Am I looking at the problem broadly and from a variety of angles? Have I examined all of the complexities of the problem? Is this a relevant question or problem to examine? And is this an original question to answer? In his book on visual thinking, Robert McKim states that it is important for creative thinking to move across vehicles of thought, from numbers to verbal language to visual imagery. We also argue that it's equally as important for cultivating critical thinking in addition to creative. We'll be talking through this lesson about visual thinking as that other mode, because that mode is most often absent or reduced in the classroom. So why is multimodal thinking important? Intelligence is distinct and diverse. We think in all the ways we experience the world. We think visually through sight, we think audibly through sound, we think kinesthetically through touch, abstractly through concepts, and kinetically through movement. In her book, Writing Design, Words and Objects, author Grace Lees Maffei argues that when we are making images, we are foregrounding meaning. When we are reading, writing, and speaking, meaning is unfolding over time. And it is through this reciprocal process and the translation that occurs that students can summarize, foreground, and understand better what they are trying to say and how. The anthropologist Melford Spiro argued that by making the familiar strange and the strange familiar, teacher and student alike come to view the familiar with a greater degree of objectivity than would otherwise be the case. Multimodal thinking and the incorporation of visual thinking in particular can be a powerful instrument to achieve these goals. In his book, Experiences in Visual Thinking, Robert McKim outlines three components of visual thinking. Seeing, which is inputting or reading and requires visual literacy and or visual development. Imagining, which might include formulating, processing, testing, and sketching, planning, synthesizing, communicating, and output. Visual thinking and seeing provides opportunities to bring in prior knowledge, use existing visual literacy, build confidence, encourage critical observation, read information, make connections, see patterns, make comparisons, and identify gaps, problems, and contradictions. Dr. Maria Gallardo-Williams, teaching professor and director of Organic Chemistry Lab and Think Faculty Fellow, used model-based reasoning in her introductory course to help students better understand the fundamental structures of the carbon atom. One of the reasons why students struggle in organic chemistry is because they are required to master three-dimensional skills. If they only read their books and solve problems on paper, the students that will succeed are those that don't have difficulty with translating three-dimensional objects to two dimensions, which is not a large percentage of the average student population. Using chemistry molecular model sets is a way to overcome this difficulty. Students can be shown how to manipulate model sets in class or outside of class using video resources and given exercises to make the connections between the flat representations and the actual shape of the molecule. Students can also be asked to construct molecular models using common household objects. This makes them take ownership of the visualization process and results in improved student outcomes. Edward Muybridge's powerful studies of human and animal movement broke apart what appeared as seamless action to study the parts of the whole more fully. As the first scientific study that used photography, and through a partnership with Penn, Muybridge's animal locomotion opened up an entirely new way of thinking about photography, human and animal movement, and even the concept of time. Imagining is also a critical product of raising questions and formulating problems because it frees us from the constraints of the everyday. Visual thinking as imagining can be reality-oriented or illusory. It is culled from your entire being and knowledge base. It is the mind's eye. Einstein is famous for his imagination, saying that imagination is more important than knowledge because knowledge is limited to all we know now and understand, while imagination embraces the entire world and all there ever will be to know and understand. Einstein is well known for having vivid and completely fantastical dreams that inspired his theories, such as the theory of relativity, where he imagined himself traveling along a particle at the speed of light. Imagination as a component of problem definition is helpful for translating from one context to another, for planning, exploring boundaries, balancing parts in the whole, and using analogies to think of one thing in terms of another. Speculative scenarios are a strategy used to encourage structured imagination for problem solving. In speculative design, future scenarios are used to create a context for problem solving. The industrial designers and researchers Anthony Dunn and Fiona Raby use speculative design in their work. In this example, imagining that food scarcity has increased to such an extent that humans are forced to start processing previously inedible plants like tree, bark, or grass. Through the design process of what a contraption might look like that would help a person digest this food, students can more visibly see the complexity of a problem that this particular solution addresses, and possibly, and more specifically, what it doesn't address. Leonardo da Vinci was well known for his sketches and recording his wild ideas, some of which required basic principles and inventions to be somewhat realistic. One of the central values of sketching is that by pressing ideas out into a concrete form, it forces a reconciliation with some of the details of a more abstract idea. And if we can help students see it as an iterative process, we can frame it as a tool rather than an end stage of a design or an artistic or an ideation process. Sketching can be instrumental in testing conclusions, narrative or argument, creating hierarchy, organizing elements, describing relationships, and proposing solutions. Part of the value of visual thinking is also as a complement to more abstract thinking. Many of you with elementary-aged children have seen homework like this, where students are asked to solve the same problem multiple ways, or use multiple strategies. You see here the student using standard math processes and then making a visual diagram to solve the same problem. It is important for us to equip our students with tools to look at problems from many different angles as problem-solving techniques. What this type of thinking encourages is a translation from the abstract to the concrete and back to the abstract again. In moving through these different vehicles of thought, a deeper understanding of the material emerges. In the 1854 cholera outbreak, Dr. John Snow could not convince other doctors that cholera was potentially being spread by other means other than miasma or bad air. He thought it was likely being spread through the water. The outbreak area had recently been provided with new sewers, but the well which fed this pump was only 3 feet from a remaining oil cesspit. To support his theory, Snow charted the deaths in the area of London which was particularly hard hit. He then plotted the location of local deaths in relation to the local water pumps, which are the black bars on the map, which directly correlated to deaths in the exact location of the Broad Street pump. The outbreak subsided very soon after, and the intervention was hailed as a success, though John Snow carefully and professionally noted that the end of the outbreak might well have occurred anyway due to the massive flight of residents from the area which always followed outbreaks of cholera. But these maps still stay as visual evidence of the power of pattern finding and research. Routine and systematic visualization can also help students create systems of logic for examination, with behavioral data such as this more lighthearted look at creative routines. This visualization allows for multiple levels of reading, including where there is similarity and differences between routines, and encouraging the examination of this data at multiple scales simultaneously. Similar to the exercise introduced in the lesson on self-reflection, visual thinking as seeing can also be used to help students recognize the previous knowledge that they bring to a class and to start integrating what they are learning in your class with life and courses outside of it. This examination can be a great conversation starter, especially when looking at topics or ideas that students might think they know, but might also have multiple dimensions to how we understand them, describe them, and evaluate the impact that they have. This particular example is taken from a sophomore level design studies course at NC State, where students were being introduced to the importance of critical evaluation in the critique process. A series of images of design objects were handed out to the students for examination. A better known one like the smart car might also be mixed with lesser well known, such as the ostrich pillow. Then, to get the students to move across vehicles of thought, the next step was a free writing exercise. Free writing is a strategy to help get the juices flowing for both critical and creative thought. In free writing, you write for a shorter period of time without stopping. The pen, the pencil, or the keyboard must stay in motion for 2, 3, 5, or 10 minutes. Stream of consciousness is encouraged, and tangential or lateral thoughts are also encouraged. You may also do this digitally, but fingers must keep moving for the same period of time. The purpose of free writing is to capture ideas and sentiments, not to craft a perfectly articulated paper.
After the observation stage, students are asked to describe the image, including anything that they might know about it. It's important that it's clear to them that they are not expected to necessarily know anything about the image and might be normal to be confused or unfamiliar with it, especially the particulars of it. They then write down questions that the image raises for them about the object use, its history, its development. Finally, and because this particular example is situated to prepare students to think about the impact of design objects on culture, the final step is to write down the ethical dilemmas that are raised by this image. These could be assumptions about what the ethical dilemma is this image is solving, or what ethical dilemmas it might raise, etc. This exercise can be done individually or as part of a small group where students must negotiate the description, meaning, impact, etc. The state, explain, exemplify, and illustrate, otherwise known as SEEI, is a great exercise when introducing new concepts, ideas, and/or terminology to students. It encourages them to go beyond the initial definition and translate it in a number of ways. The exercise starts out by giving each student or a group of students a word or idea. First, students write the definition. You can have them look up and summarize an existing definition or write it verbatim from a source that you supply or they find. The second step is to explain the definition in other words. Next, they need to give an example of that word in context, and finally, create an image that supports the definition or example. This can be an illustration, a diagram, an animation, or another representation. It's important for them to actually draw or create the image rather than finding an existing one. In addition to using this exercise for terms and ideas that are new to students, it can also be used to have them explain ideas that they might implicitly or anecdotally understand, but haven't explicitly articulated. You can see here that in defining design collaboration, the student is first using an expert source to state that collaborative design is a process that brings together different ideas, roles, and teams that can also involve planning and strategy developed by user feedback. Then, explaining it in other words, they wrote that design collaboration involves several different individuals with different skill sets working on the same project in order to create the best possible product and allowing for more expansive ideas to be generated. The student then gave an example of designing an app where some people are going to focus on coding, some on content, some on graphics, but communicating all to ensure the best possible product. The final illustration is a fun and aspirational interpretation, with the rainbow and each person on the collaborative team communicating with each other. This exercise can also help you as the instructor know when or where students are on or off the mark.
In reflecting on the ways that multimodal thinking can be encouraged in your course, we might think about the way that the same material could be expressed through different modes of visual thinking. We might prompt students with questions about context, relationships, and patterns, see this as an iterative process and help students to see it that way as well, and use sketching to externalize knowledge and thinking.